So here's a first order. Well, let's look at it first. We get it, and there's trig, sine squared. We're thinking of all this, but let's take a minute and notice that it's y prime, so it's first order. It's linear. If it's linear, then we have a plan. Now, it might be also separable, but I'm not even thinking about that. I see that it's linear, first order linear, so I want to put it into the form y prime plus py equals q. That's what I want to do, because then I have a method. The method is I have an integrating factor, which is e to the integrate p dx, multiply through the y prime plus py equals q, and then I can integrate both sides. So that's my plan. The first thing I notice is that it's not in the right form. It's not in the y prime plus py. So let's take this and put it in that form. So we just want y prime alone. So let's divide everything by sine. Everything by sine. So cos divided by sine, that's cotan. Sine squared divided by sine, that's just sine. So we've divided everything by sine. Now it's y prime, but it needs to be y prime plus py. So I'm going to move this cotan x times y over to the other side, and so it becomes a negative. But I'm going to put the negative inside the bracket because I want to emphasize that it's y prime plus py. So the p is negative cotan. So let's get our, now it's in the right form, y prime plus py equals q. So let's get our integrating factor, e to the integrate p. So e to the integrate minus cotan. Now, we got to, this one's got trig in it, so we got to know all our trig integrals and differentiating. So that's going to be e to the, if I integrate cotan, I get, well, if I integrate cotan, I'm going to get minus the ln of cosecant. The minus is already there, so the ln of cosecant. Now let's just check this to make sure that we did this correctly. If I differentiate the ln of cosecant, that's going to be 1 over cosecant times the derivative of cosecant, and the derivative of cosecant is minus, I know it's minus because it starts with a c, minus cosecant cotan, and the cosecants cancel out. So I'm good here. And it produces this minus for me. Now, if the e and the ln show up, I want to cancel those out. I want to use the fact that ln and e are inverse functions. So e to the ln something is just that something. And so the integrating factor, the thing I multiply through each side by, is cosecant. Now, if there would have been, there isn't, but if there would have been like a 2 or something out front, then I would want to bring that 2 up as an exponent before, so I would have exactly e to the ln something. But it worked out nice that there wasn't any extra piece there. So I've got my y prime plus py equals q. I want to multiply everything by cosecant, all three sides. So cosecant, cosecant, cosecant. So I'm not simplifying yet, I'm just multiplying through. Now, this side with the y prime and the y, that always integrates to be y times the integrating factor. I mean, we can check it by doing product rule. Derivative of the first is y prime, leave the cosecant alone, plus leave the y alone. The derivative of cosecant is minus cosecant cotan, so it works. So from this step to this next step, I'm integrating both sides. Now I need to integrate cosecant times sine. Well, cosecant times sine, cosecant's 1 over sine, so that's just integrating 1. So that's x. So from this step to this step, I've just integrated both sides. Oh, and I can hear you yelling, plus c. So let's put that in there. Exactly in the step where we integrate. And now, technically I'm done. This is the implicit solution. If I wanted the explicit solution, let's just solve for y. I'm going to multiply everything by sine. So that's going to be x sine x plus c sine x. If initial conditions were given, then I could get what the c is. There wasn't, so I'm done. I was done here if the question was just solve or find the implicit solution. I am done here if it was what's the explicit solution. So this looked really bad because it had trig in it, but it was just first order linear and it actually worked out pretty nicely.